My name is Thomas Block and I'm product manager for environmental sensors at Bosch Sensortec. Today I will talk about environmental sensors in smart home applications for a better quality of life. So first, who are we? Who is Bosch Sensortec? So Bosch in general is a global market leader in MEMS sensors, and Bosch Sensortec is a subsidiary of Robert Bosch GmbH and was established 15 years ago. So we have a broad portfolio of different MEMS sensors and are visible in all kinds of CE products like smartphones, tablets, and all others, hearables, wearables, many products. So we are a global company and started the MEMS production overall at Bosch in '95. So far we produce an impressive number of over 15 billion MEMS sensors. And I want to highlight that the MEMS production is 100% in-house, including engineering and MEMS design. So what is our value proposition? So we are also a technology leader, not only for sensors, also for MEMS solutions. And we have all important in-house technologies, including ASIC and packaging, also developed worldwide. On top, we have a global support organization and systems capabilities. This includes, for example, hardware and software support. And last but not least, we also have a global supply chain which supports our capacity and have proven processes and high reliability organization. So here you see now our broad portfolio of MEMS sensors. It's divided in motion sensors, in environmental sensors, in smart sensors and optical microsystems. On top we have a broad portfolio of software and algorithms, including AI solutions. Okay, and now we are coming to the more detailed view of our solutions for smart homes. We start with barometric pressure sensors. Where can they be used in smart home applications? It can be used for use cases like fall-down detection, indoor localization, intrusion detection, cloud-based services, and smart home use cases, for example, in home appliances. In smart home use cases, so these are, for example, home appliances like vacuum cleaners, where you can detect clogging, or you can detect the water level applications, for example, in washing machines. Cloud-based services is related to weather mapping, so means weather forecast, which can improve with the pressure sensor the accuracy of weather forecast applications. Indoor localization means at home you can better localize someone where is located in which kind of floor level with the help of barometric pressure sensors, in addition to GPS, which are normally not working indoor. Intrusion detection is a very interesting use case because with a barometric pressure sensor you can detect if someone is entering a house, your apartment, intentionally, or is he someone who is maybe not allowed to come to your home, and the pressure sensor in combination with microphones, maybe also accelerometer, can detect if, for example, a window is crashed and someone is entering your house or apartment. Fitness tracking is an upcoming use cases mainly for wearables and hearables, but also in smart home applications can be used that the barometric pressure sensor is detecting the movements you are tracking, where you are going, and also calculating fitness applications, for example, the calories expenditure. And fall down detection, very interesting, for example, for elderly care, or to detect if someone is falling down and maybe triggering a call for emergency, for example, that the person needs help. And here we again have the use case with barometric pressure sensor, including sensor fusion and accelerometer. Indoor localization. So this use case of locating someone indoor is getting reality now, especially in the US. So when you have an emergency, normally you call E911, and but when, for example, you are not capable to call someone, at least you can detect someone when at least you called 911. And here automatically the barometric pressure sensor helps indoor to locate the floor level where GPS is not working. And in this year it was officially launched, and the FCC is now requiring mandatory pressure sensors in all smartphones and all, especially products which have a SIM card. Airflow measurement and intrusion detection is one of the upcoming most important use cases in smartphones. Clog detection means you have a vacuum cleaner and know if the bag, for example, is full and you have to replace it. Other use cases I mentioned are, for example, to detect the airflow, also in the vacuum, maybe to adjust the motor and get a better suction and help to increase the performance of a vacuum cleaner. Detection intrusion, it means you need a barometric pressure sensor, like I said, when you want to know if someone is entering a building. Not only, for example, for intrusion detection, but also maybe you can adjust your HVAC system, your heating system, because a window is open, someone is entering the room, and you have maybe to compensate a cool down period. Or at least give an alarm that you are heating and you unintentionally opened a window which you now may close. The barometric pressure sensor also can detect water levels. This is important for washing machines to reduce the water consumption and, for example, have a better energy overall consumption. Environmental sensors in smartphone application also means you can now better say, is it the weather going better or worse? And here, for example, you may know that what weather stations are available worldwide. So weather stations are used to make a weather forecast, but when you think of most of the weather stations are maybe not where you are staying. So it's not very accurate when you only use weather stations nearby, maybe 100 meters away, 1 kilometer away. I think it's clear that it's better to have also maybe the usage of barometric pressure sensors from your home system, from your smartphone, and then you can use it as a solution to use it in your smart home system to better, for example, forecast the weather situation and maybe adjust your HVAC system, your heating system, according to this weather forecast. And here the apps already available, and also there are suppliers, for example, thermostat suppliers who are using this to have a better energy consumption and overall better strategy, like for example, to adjust your heating cycles. Humidity and temperature sensing, very important for home applications. As you know, the indoor application, the indoor climate has a big influence on your well-being. What kind of temperature you have, what kind of humidity level. It's very important to monitor your room climate, especially when you want to monitor your HVAC system and want to maybe adjust the ambient temperature. Factors here are important, not only temperature, humidity, also the air circulation. And here also pressure sensor can help. The ambient air humidity is very important, especially when you're outside of the recommended range. Here there are official regulations and recommendations to say between 25 and 70 degrees relative humidity is the optimum. For the temperature, it's something around 20 to 25 degrees. So when the limit is, for example, not met, when the humidity level is too high, then, for example, you have a problem of mold growth, for example. And this is a health issue. For example, it can trigger allergies, sneezing, nasal congestion, running nose, or itchy watering eyes. When you have a low humidity level, this in contrast is responsible for irritation of the eyes, and for example, you get problems with your lung system. So it's very important to keep the recommended humidity and temperature level to prevent health issues. And here, humidity and temperature, the sensor can help, for example, the beam E280. When it comes to prevent mold growth, you have to know that regularly, when you look at the global situation, around 20% of the households are at least have an issue with mold growth in rooms which are affected, and especially here on the inner walls. So this can be really a problem also in renovated buildings. For example, when you make a change and you have untight isolation, when you change maybe only one window and it's not really fitting, you can get a problem with mold growth. And here children are very likely to be affected by this, because when it's in the sleeping room, when it's in the bathroom, it can really have a significant effect on the health of people, especially babies. So why is this? So mold has best conditions when it's in temperatures between 15 and 25 degrees. And especially mold likes humidity. So when the humidity level is too high, it's also something very critical. And to keep this under control means you have to monitor the humidity and temperature level. Otherwise, you again will run into health issues. You get problems with your respiratory tracts, for example, nose and lungs, and you maybe get allergies and other health issues. When we come now to air quality, I want to highlight that we have with the beam E680 already all other sensors inside the sensor which I mentioned already. The beam E680 is not only a gas sensor, it's also a barometric pressure sensor, it's a humidity and a temperature sensor. So it's a 4-in-1 solution. So you see here what kind of technical details we are using here. For example, the temperature diode, we have a resistive humidity sensor, we have a piezo-resistive pressure sensor, and we have a gas sensor which is based on membrane which are heating up and metal oxide. So when we come now to gas sensing, it's widely used, but I will focus on the smart home applications. And here indoor air quality is the most important topic. And indoor air quality is not only related to CO2, because when you look at a home, there are more sources of bad air than only the human being. It's coming out of, for example, furniture, out of the wall. There are many sources for bad air. Last but not least, I want to highlight the new development and the very important use case, how it can help to avoid the risk of an infection. So the beam E688 and our smart algorithms can prevent the risk of a virus infection. And here the reason is it has a humidity sensor to detect dry air, for example, which makes it easier for the virus to connect. It has a room temperature measurement. Also, you know, in cold air, the virus has better survival conditions. And last but not least, the air quality measurement can detect if a high amount of exhaled air and aerosols are present. Means when you detect and help to have a good air quality. You monitor it first, and then you can prevent this ventilation that, for example, a bad air quality increase the risk of infection. For example, open the window, increase air condition, increase ventilation. Conclusions. Here I summarize my talk, and it's especially important that we have as BST all important sensors in-house to measure smart home applications. Highlight is the BEAM E688 with humidity, temperature, barometric pressure and gas sensor. And I want to thank for your attention and looking forward to join and see you again. Thank you very much.